In this series of videos, we're going to be learning how to solve exponential equations using logs. And I wanted to, before we get into that, I wanted to make sure we reviewed solving exponential equations using exponent properties. So there's two different ways to solve exponential equations, and you're going to see both of those ways in these videos. So solving exponential equations using exponent properties, we know when we have 2 to the x is equal to 8, we recognize that both 2 and 8 can be written as a power of 2. So we just rewrite 8 as 2 to the third power, and then when we know that when the bases are the same, then the exponents also have to be the same. So therefore x has to be equal to 3. Let me get my different color here. So x has to be equal to 3. So that's the basic format behind solving exponential equations using the properties of exponents. And then when we get problems that are a little bit more complicated, we have to then again recognize that both 1/4 and 32 can be written as a power of 2. So we know that 1/4 is 2 to the negative 2, and we still have to raise that to the x minus 1 power. And then we know that 32 is 2 to the 5th power, and we raise that to the 2x power. So then again, when we have power to a power, we multiply the power. So we know that negative 2, hold on a second here, keep changing the colors. So we have negative 2 times x is negative 2x, and negative 2 times negative 1 is positive 2. And on the right side of the equals sign, we have 5 times 2x, so that's 10x. And then once again, we have the bases are the same, so once the bases are the same, we equate the exponents. And I'll just stop there, we don't need to finish that. So we have negative 2x plus 2 equals 10x, and we can solve that for x. So that's the review. That's the one lesson that we did prior to now solving exponential equations using logs. So the first thing though, and I'm going to start a new video for once we start the examples, but what I want you to focus on is there's three things. So the bread and butter is where you have to remember this. So you have to remember that when y is equal to a to the x, that's an exponential equation, and it has an equivalent equation but using logs, and that would be up here in this box. So we've got this box up here that you have to remember the equivalent equations, both written in exponential form and then log form. So that's one thing that we have to remember. The other thing that you may not know is that when you see the log base e of x, that's the same thing. Let me get this in green here. That's the same thing as writing it as ln of x. And so there's a button on the calculator that has an ln on it, and there's a button that has an log on it. The log is base 10, ln is base e. And so I should probably write that here. Log of x is the same as log base 10 of x. So when you just see log without a base, it means the base is 10. And again, whenever you see an ln, that's the same as the log base e of x. If you want to write it as log base e of x, help you solve these equations, that would be fine as well. And then there's this other thing that you need to remember. It's called the change of base formula. And this is helpful when we want to type in the expression into our calculators. We only have a base 10 and base e on our calculator, so we need to be able to solve exponential or evaluate exponential or logarithmic expressions with different bases other than 10 or e. So all you have to do is notice that the b and the a are the two numbers here that we're looking at. The b is at a higher position than the a. That's how I look at it. And so all we have to do is and we'll do this when we do some of the examples, but log of b over log of a. And we could also change the base to base e and write ln of b over ln of a, and we'll do a couple of those when we do some examples later on. So those are the basics, and in the next few videos I will show you some examples.